Let's go to LeetCode 2863. Maximal length of semi-decreasing subarrays. For this question, it gives us an integer array. And let's find the longest semi-decreasing subarray of nums. So what is the semi-decreasing subarray? First thing is that this subarray, also the first element is strictly greater than its last element. Let's look at the first example. We'll see the longest is this one, right? 7 to 6. 7 is greater than 6. So the longest length is 8. And the third example, because it's monotonic increasing, so it is 0. So for this question, what we're thinking about is that possibly we can sort these numbers into a descending order. For example, 11, 10, 7, 6, 5. There are 2 6 here, right? 6, 5, 4, 3, 2, 1. So we know the index. If we sort, the index will be masked, right? So we need to sort with the index. So we see this 7 is index 0, and this 6 1, right? And there is another 6. This 6. Let's decide which one will be 1, and 5 will be 2, right? 2, 3, 4, 5, 6. And here 6, 1, the index 1 of the 6 is 7, 1 is 1, right? And 8, 9, right? So we know we want to if we want to see the longest one, what we need to do is that we need to have the bigger index to be smaller than the smaller number index. The bigger number index will be smaller than the larger number index, smaller number index, right? So we want the smaller to be end and the bigger to be front. So we can iterate this one, right? So we'll see this is 9, right? So that means this is already the biggest index. So it's impossible to have a semi-decreasing subarray start with 11, right? So actually, we look at this one. This already is the last one, so it's impossible, right? And 10 is 8, right? So after 8, we cannot find this is index 8, right? So after this kind of sorting array, we cannot find an index greater than 8. So that means 10 is not possible to form a semi decreasing subarray, right? But for 7, you see, after that, we can find those kind of subarray which has a index greater than 7th index, right? So actually, we can look at after that we can look at the biggest will be 6, right? So the longest will be 6. For start with 7, the longest will be 0 minus 6 plus 1, right? So in this case, we can doing things like the array subarray start with 7. The longest will be 7, right? But we find an issue is that we use a start, right? Start the things that we iterate this kind of loop arrays, and for everyone we check the rest, right? That we use 2 for loop, right? For loop that will be O n square. not good times complexity. So what are we about? We're thinking about end, right? So if we want to end, what we want to is that, for example, we find a 9, right? If we want to have a semi-index, we want to see in its previous one whether there is whether there is any in its previous one, whether there is any index smaller, right? So we want to see in its previous whether there is any index smaller, yeah, correct, than current one. So we can use a mean left index variable trying to record the smallest index we see in so far, right? So for example, this one we didn't have a left mean, so this we cannot form it, and for H, right? So the left mean, let's see, this index, because we set the left mean index as integer max, right? So after we go to 9, we after the left mean to be 9, and 8 index is smaller than left mean index. That means we cannot form, right? And 7, the same thing, right? And after we go to 7, then we find that we update the left mean index is 0, right? So that means this will be one of our the when we iterate later, right? We can use current index and the left mean index to form the longest semi decreasing subarray. So we go to iterate every sorted array, right? Find its index, trying to update the left mean, and also use current index to form to get to the current length and update the total length. There is one thing, right, about a duplicate number. So if we sort this number in decreasing order, and if there are 2 6, which and their index is 7 and 1, right? So which one will be placed in the front, and which one will be placed in the middle or in the end, right? The thing is that for this kind of what we want to do is that for this kind of because we want to have a strictly greater, so that means for the same number we cannot form any semi decreasing subarray. So we want is that for every those kind of duplicates in its front, we cannot find a smaller index of it, right? So in that case, what we do is that we sort the whole array in a decreasing order, and when for those kind of duplicate numbers, we also sort in a decreasing order. In this case, for example, this we put, for example, this is 7, right, and 1, right? So in this case, you see for 6, it's impossible on its left there is any index with the same number which have the index smaller than 1 if we also sort this in decreasing order, right? So let's formulate the steps. One is sort, right? Sort by numbers. If the same they are duplicate numbers, sort by index. They are all in decreasing order, and then have a left mean index, right? To we can still set this one as possibly how can we say that? We can set the first one, right? Then iterate from the second index, and when we upgrade, when we iterate from second index, we try to see if current index is smaller. If current index is greater than left mean index, then that means we can form a semi decreasing, right? If it is not greater, then that means the current index is smaller than previous one, right? And we cannot form. But we every time we iterate this index, we should update the left mean index. So after this analysis, let's try to write code for this. Let's have int n equals nums of the length, and because we are going to sort, and so we need to have the in those kind of index to be together with it. So let's create a new array equals new int n 2, right? So what we do is that for int I equals 0, I smaller than n, I plus plus, array I 0 will be nums I, and array I 1 will be I, right? So we have two dimensional sorts. One is by the numbers order in a decreasing, and when the number have the same value, we sort by its index in decreasing, right? So arrays sort array, we can use the lambda, right? A 0, A B goes to A 0 equals B 0. If we equals, right, equals, then that means the value equal. Then we sort by its index, right? Index. Let's sort in decreasing order. Compare B1, A1. Otherwise, let's sort by its number, right? B0, A0. Okay, so these are sorts. And let's have left mean index into left mean index equals array 0, 1, right? So we know we need to have a result, which is the longest semi-index length, right? And so now let's iterate for int I equals 1, I smaller than n, I plus plus, right? So we'll say if array I 1, if this index, you'll see if this is smaller number, the index is greater than left mean, right? Then we have a semi decreasing subarray. So what we do is that we going to have max trying to upgrade the global result, right? And our array I 1, we should minus the left mean index and plus 1, right? And for this one, it's because this kind of index, it will not have a duplicates, right? Index will not have duplicates, so we'll have else. Else, that is our array I1 is smaller than left index, so we'll have the left mean. Sorry, so we'll update left mean index. equals array I1, right? So in the end, we just return result. Okay, there is a sorting. So this is an n log n time complex space is O n space